We're now going to have another company that's building on top of Flower discussing their work. And so we're going to welcome Orlando and Jan of the company Katulu, and they are going to give a talk that's entitled Going to Production with Flower. So it's over to you.
All right, hello.
Hi.
Orlando here. Yep. So we're Katulu, and we're building tools and solutions to really just break down barriers for collaboration, enabling organizations to jointly work on and solve the big challenge they can't solve themselves, right? Like, for example, circular economy, where you have many different manufacturing companies needing to work together. But there's a problem in the industry because they're never ever going to share their data, like never ever. And it's for good reasons. There's laws, there's this security considerations, privacy concerns. There's a whole topic of that I would coin cloud angst, where they just really don't want their data anywhere near the clouds. And that means there's really no data, really, and no data, no insights, right? So, well, the solution is apparent, right? Federated learning to the rescue. So when we came to this point, we kind of looked into different solutions out there, and we had this super long list of requirements, from things that really are around the Federated Learning Framework itself. It needed to be agnostic because we knew that we need to support different frameworks to accompany the users. There was security things like zero trust, and it needed to be an actual secure connection. There's a whole topic that isn't that much tied directly to federated learning, but it's around the integration of it into the industry or production environment, where it's about edge management. Hardware needs to be hardware agnostic. And then it's about running the server in the cloud, and the deployment of it needed to be cloud agnostic. It needs to kind of bring all the tools like notebooks and whatnot with it. And then the last thing, it needs to be easy, right? It's like we're talking about mechanical engineers that started to kind of learn AI and maybe went through a few Kaggle experiments, but they want to use this. So we tried a bunch of different frameworks out there, and eventually settled on building something on top around Flower. And that is what we've built. And with that, I hand over to you, Jan.
Yeah, thank you. Let me share my screen here, and let's do a live demo if I can find, yeah, here, the right window. I hope you can all see that right now. So yeah, we built a platform that's called Katulu FL Suite. And it's basically what Kubeflow offers, just on top, suited for federated learning. And I already have a notebook running here, and I'm just going to start a few things here and then explain what's happening. So I have prepared a notebook here, and I'm just doing this, and this. And now we have something being created here, which is a in Kubeflow, which is a run. And it's now preparing something. So let me explain what's happening here and what problems we are all solving here. So first of all, this is, well, in Internet of Things speak, there are edges, which are in Flower speak more or less clients connected to a server, and we need to here run a Flower server and have clients connect to that. But that's not all. First, these clients need to know what to actually run there, and they need to have a secure connection to that. While Flower offers secure connections, we also need to do more here. We also need to distribute the work that the clients are going to do to the edge clients. And for that, we need to define them. There's multiple ways how to do that. We chose a very simple one, but also pretty heavy one, by just packaging these things as Docker packages, as Docker images, and then distributing them to the clients. And this is what we're doing here as part of in this notebook. So this might seem familiar, this code here, because it's actually the TensorFlow quick start of the Flower client. Just a little bit of changes here. I'm using the MNIST dataset instead of the Cypher 10 dataset because the training is much faster here, and we don't want to spend most of the demo here waiting for the training to finish. So we also have a different model here because all the existing image models usually don't take input shapes smaller than 32 by 32, and well, MNIST is 28 by 28. But the rest is more or less the same. So we are starting a Flower client in the end. We are connecting that to this particular address, which is a proxy, because everything is then handled inside of the edge clients to have a secure connection. And we are packaging this by using a Python decorator, which indicates that this is the code for the federated learning client that we want to run here. And as this is then, as we are then creating a full image out of that, a Docker image, we have to put in more information into that. So what packages to install first, and then this takes care of, well, first building this image and then distributing them to connected edge clients. So by doing this pipelines run here, we are then instructing our suite to do all the necessary steps to create the images, distribute them, and start the training. And we can take a look at what's happening here. So we have in Kubeflow, this is a pipeline that has these steps separated here. One is we have to set up this Flower server. The Flower server is already running here, and it's already waiting for clients to connect. But these clients are not ready yet because we are building the image for them on the go. This is already happening here. I think it's already pushing these. So the platform we have is hosting a Docker registry, and the connection of the clients is securely accessing this Docker registry. I think we are finished here now with that. And well, so in that sense, we are making this all secure to use. There's a secure connection for each of these clients that are connected. And we have at the moment 2 clients connected that are now just, well, getting, this also part of our solution. We have a mechanism here to inform the clients, the edge clients, that there's new images available, that they should start first downloading these new images and then execute them to start their training. And this is all happening automatically. We have 2 edge clients running, and they should connect soon. This is the scary part of the demo because this is all happening live on 3 different computers. So there's the cluster we are having running in Amazon Web Services, and we have a client on my computer. There's another client in a different part of the city in Alando's computer, and they are now, well, being instructed to first download the image we just built, then execute that image. In that image is the code we just saw, which is the Flower client. All the information necessary on how to connect and stuff like that is part of this pipeline. And soon or later, it should connect here, and these 2 clients should connect and start the training. This takes a while because, well, it needs to first download the image, and that's the scary part. Let's hope this happens soon, because then we will have a training running here, and then we would have this pipeline green, and would have then the results of that pipeline, which is, well, obviously the training results stored, and we can use them for now something happening. So the first client is connected. Let's wait for the second one. It should be in time as well. And then, of course, you can, this is something, there's more parameters to this here. I'm just using the default parameters. You can, of course, have more than 2 clients for training. You can all control that. There's a lot of parameters for this run function. I'm just using the default ones, which are making this easier to show. And let's wait for the second client to connect. hopefully should be there soon. Let's see if there's something else we can show here while we wait for the second one to connect. Yeah, I mean, this is all based on Kubeflow, this whole platform, and then of course wrapping Flower, the client and server on top of that, plus some extra special sauce to make this work for federated learning, because Kubeflow itself as a platform is very suited to, let's call it regular machine learning. And yeah, we needed to add some magic sauce on top of that to make it work for federated learning. Okay, this is already training because we're using MNIST. It's pretty fast. We are training three epochs here. This is the second. Let's just why it takes a while for the third one to run. Okay, this is also done, and I think we should be finished in a second. That's probably my computer that is slow now because it's also hosting this this Zoom call. And we're done here. So yeah, this pipeline ran through, and we still have all the information. Well, it should be green in a second. We have all the information here available. If we click on that, can go back to this run here. Yeah, we do the cleanup of the resources, and yeah, that's just a small run through of what we can do with this platform and what of the additional things on top of what Flower already provides, we are solving with this platform. With that, back to you, Orlando.
Let me unmute and then, well, there's only so much we could pack into this very, very short demo, but there's a few other things you can do. It being built on Kubeflow means that you already have a set of functionality out of the box that we call MLOps. You can have recurring runs, so you can actually schedule federated learning runs, so that you kind of make sure that your model doesn't drift if the data changes out there. You get like all these logs out there already. We're planning to extend on this. There's federated analytics that's built on top of the get properties feature that just recently landed in Flower. That is also to highlight that what we've packaged in this is the vanilla Flower. So we can always ship the very latest and greatest from Flower. And the last thing I really want to say is this is open source. Most of what you've seen is out of open source, not the entire list of kind of features, but what you've seen in the demo and these two other features, they're open source, and we like to welcome you and help us work on this. And that concludes what we wanted to show today.